Hello everyone, I am Uttam Satkute, Professor Electrical Engineering Department at Dr. D.Y. Patil Pratishthan College of Engineering, Srinagar. This video is on the course Power System Stability and Control, which is there for third year BTech. And in this video, we'll see Unit 6, that is Power System Security. Now, before going to see the definition of power system security, uh, and what are the different components involved in power system security operation. Let us first understand what are the different state of operation of the power system. So different state of operation of the power system. Now before this, let us understand with analogy to understand the state of operation. So I will take a human being. Now, as human being, I say that he is very healthy, he is normal, he is in very healthy condition, in a very healthy state of operation. Now, suppose infection, if some infection takes to him, viral or anything like that, then now if even though because of and if his immunity power is very strong, and even after getting infection, if he still remain healthy, then we'll say that he is very normal, or is very fit, is in very normal state, is in very normal state. Now suppose he is healthy, but after infection somehow he uh, felt sick, then we say that he 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 is in we can say that he is under alert state. Now he has to be taken to doctor. So we can say this is unhealthy condition. He is infected, uh, and if he is taken to doctor and if proper action is taken place, if it takes some, then he can come to healthy condition. But after the infection, if it's not taken care, if it's not shown, then his health of condition will get worse and worse, and there is that can lead to any fatal situation. So this is very similar to human being. The power system is also operated in different state of operation. So let us understand this here. The power system state of operation. The power system is operated in different state of operation. We can see here. So there are 5 states that are defined. One is normal state, another is alert state, then emergency state, then in extremis state, and then it is a restorative state. So these 5 states of operation, they are different healthy condition of the power system. So what is normal state? Normal state, it is also called as E and I. What is, let us what EI? E means equality. So here I write it is equality. Equality. Equality means what? Now you have certain load on the power system, and if you are generating as per the load demand, the active power demand is also satisfied, the reactive demand is also satisfied. That is, the PG is equal to PL and QG is equal to PL. Then we say that equality constraint is satisfied. Equality because it is equal. So if generation is as per the load, okay, then we say that E constraint is satisfied, that is equality constraint is satisfied. Now next second one is I. I means inequality. What is mean by inequality? Now in the power system there is voltage at different point, there is current, there is frequency, the line flows, the relay settings, relay of these operations and all. Now if the operating state, operating parameters in the power system, if they are within the limits, for example voltage. Now here I have written inequality here. Now, if the voltage at every point in the power system, if it is less than some maximum value and if it is greater than some minimum value, then we say that inequality constraint is also satisfied. Similarly, current, if it is say less than some I max value and if it is greater than some I minimum value, then also we say that it is satisfying uh, then also we say that it is satisfying inequality constraint. So normal state of operation, here it is written, what is normal state? Normal state means what? In this state, both equality, E means load and generation are balanced, inequality constraint, that is all the operating parameters, they are within the constraint, within the limits, maximum, minimum, are satisfied, then we say that the power system is in the normal state. So this state, it is also called as EI state. It is also called as EI state. Now, along with this, both equality and inequality constraint also the power system is robust to sustain any contingencies. So we will see in the next video what do you mean by contingency. Just now I explained with a human being that he is healthy and even if he get infected, he still remains healthy. So that is called as very fit person or very healthy person. So this state of operation is similar to that. Okay. The next state is alert state. Now it is alert state. Now in this alert state, it is called as here also it is called as E and I. Both E and I are satisfied. In this state also, both E, equality and inequality constraint are satisfied. The but power system is not that robust. Means what if not robust to sustain any contingency. So if any fault take place, then there is a possibility that the power system will become again more severe. Okay, and if corrective actions are taken, then the power system can switch to alert state. So we can understand it from here. So this is the alert state here. Uh, uh, so this is the alert state here. So in the alert state, E and I both are satisfied. Equality, inequality constraint satisfied, but it is not that robust as in the normal state. So if any contingency take place, means if some fault take place, then you can switch to in emergency state. You can switch to emergency state. Okay, and if some correction actions are taking place, then from alert state we can switch to normal state also. Okay, so this is the second state of operation. The next is state of operation is emergency state. What is this state? This is called as EI bar. Means what? E equality constraint is satisfied, but inequality constraint is not satisfied. So it is written here in this state of operation, E constraint are satisfied, but I constraint is not satisfied. Means what? The load is balanced, the load and generation is balanced, but the operating parameter, the voltage or current, they are violated. Means some of the voltages are maybe more than the maximum value, or some line flows they are exceeded beyond their limits. Okay, the stability limit or power limit like that. Now, in this state, if corrective action is not taken, then the power system may switch to inextinct state. So we can see here in this inextinct state, equality is satisfied, inequality is not satisfied. Now, if corrective action is taken place, then we can go to alert state. Means inequality constraint is also satisfied, and if corrective action taken place, then we can switch to alert state also. We can switch to alert state. Now, if the corrective actions are not taken place, then the power system may switch to inextinct state. This is inextinct state. Okay. Uh, Now, inextinct state means what? This is called as both E and I both are not satisfied. Here, both are not satisfied. In this state, both E and I constraint are not satisfied, and in this state, if corrective actions are taken, if the corrective actions are taken, then the power system can switch to alert or restorative state. Okay, so if you do some action, some uh, uh, if you do something with the inequality constraint, that some power system structure is changed, and if you bring the operating parameter voltage and current within the limits, then we can switch to restorative state. So you can see it here in the diagram. Uh, uh, So here both E and I are not satisfied, but if you do something with inequality constraint, then you can go to restorative state where E is not satisfied, but equality constraint is satisfied, and from there you can switch to this normal state. Okay, and if there is a possibility that if the corrective action has taken place, then there is a possibility that you can switch to alert state also, where E and I both are satisfied. Now, a restorative state, this is restorative state. Here, in this state, E is not satisfied, equality constraint is not satisfied, but inequality is satisfied. Now, in this state, if some load shedding is done, okay, equality constraint is not satisfied means what? Power balance is not there. Means some load shedding is done or some generation, something is changed. Then there is a then you make the power balance, and from this state you can switch to the normal state, or you can switch to also alert state. So these are the different state of operation of the power system uh, in which the power system operates. And what is power system security? That is what the final is, that what is power system security? Means what? If we are operating our power system in the normal state, wherein E and I both are satisfied, the power balance is also there, and all the parameters they are within the constraint, then we say that we are operating power system in the more secured manner. And the objective of power system security is to operate in this state. If it is there in any of the other states, then the actions are taken and try to bring it to the normal state. So then we say that the power system is more secure. So in this video, up to this only, we will continue in the next video. Thank you.